Hello and welcome to IEEE SA's very first Li-Fi live stream, How Li-Fi Could Revolutionize Wireless Communications. I'm Corey Ruth, Marketing and Communications Manager with IEEE SA, and I'd like to thank all of you for being here today and watching. Whether you're watching this live on LinkedIn, YouTube, or Facebook, or if you're catching the recording afterwards, we really appreciate you being here. So we're going to talk about Li-Fi. You may have heard about it in the news, heard people talking about it, but what is it? How does it work? And what practical applications might it have? If you're seeking answers to those questions, you've come to the right place because we have experts from the IEEE 802.11 working group who can answer these questions and more. Just before we get started, I'd like to take a quick moment to mention that we really appreciate your feedback. We want to make sure that we're providing content that's relevant and important to you. So if you like what we're doing here today, or if there's other things you'd like to see, or other topics you'd like us to cover, we want you to let us know. Towards the end of this video today, we are going to put up a link and a QR code for a survey. We really would appreciate if you can take just a couple of minutes to fill that out and provide us with the important feedback to help improve our content and provide things that are most relevant to you. So watch for that survey at the end. Also, you may wonder, who is IEEE SA? Why are we here today? Well, the IEEE Standards Association, or IEEE SA, is a leading consensus building organization that nurtures, develops, and advances global technologies through IEEE. We bring together individuals and organizations from a wide range of technical and geographic origins to facilitate standards development and collaboration. We have thought leaders in more than 160 countries to promote innovation, enable the creation and expansion of international markets, and help protect health and public safety. Collectively, our work drives the functionality, capabilities, and interoperability of a wide range of products and services that transform the way people live, work, and communicate. And why we're here today, as I mentioned, Li-Fi. All of the world's internet in one way or another traverses the 802 IEEE 802 network that includes Wi-Fi and Ethernet. And today we're talking about a new evolution in that technology, IEEE 802.11bb, or Li-Fi. As I mentioned, we've got a couple of great experts for you today. First off, Nikola Serafimovski. Nikola has more than 10 years experience working in light communications, specializing in Li-Fi technology and its commercialization. He's the current chair of the IEEE 802.11 Light Communications Task Group, the vice chair of the IEEE 802.15.13 Task Group on multi-gigabit optical wireless communications, and the VP of Standardization at pureLIFI. Joining him will be Tuncer Baykas. Tuncer is the vice chair of the IEEE 802.11 Light Communication Task Group and senior technical staff at Ofinno. He's contributed to many standardization projects, including, as I mentioned, the Li-Fi task group, but also IEEE 802.15.3c, IEEE 802.11 AD, and IEEE 1900.7. So without further ado, I will welcome Tuncer and Nikola. All right, so I'm hoping you can give us just a quick overview of what is Li-Fi. Nikola.
Yeah, so Li-Fi is really the high-speed mobile wireless communications using light. It is really designed to complement existing Wi-Fi in just using another part of the spectrum. It is this concept that we can use light, which has been around for many, many years, but really the innovative element is to provide it on a networked, pervasive approach. And the entire premise behind it was, conceived back in 2011 by Professor Harold Haas that we can have Li-Fi everywhere. We can have communications using light in locations where RF is not desirable or not permitted, and actually even to just help offload a lot of that congestion that's happening on your Wi-Fi medium to the light spectrum, which is in itself unlicensed or license exempt, I should say, really safe and of course pervasive everywhere.
Okay, excellent. And I wonder as well, can you give us a little bit of background into the IEEE 802.11bb standards development process? How does that work? How does a standard like this come about? Maybe we'll have Tuncer.
Thank you very much. Thank you very much for having me. Uh, IEEE 802 actually recently celebrated its 40th year during the COVID years, so we have a well-established development process. In IEEE 802, there are different working groups specializing in different technologies, such as 802.3 is for Ethernet technologies and 802.11 is for Wi-Fi technologies. 802.11bb is a part of the Wi-Fi technologies. And in that working group, we have a wireless next generation standing committee. If you have a new idea, usually you make a presentation about your idea and then if there could be a new project on this idea. And Nikola and I, and among many people, actually started giving a talk in the wireless next generation group. Afterwards, since there is enough interest, we started a technical interest group on the Li-Fi systems. In the technical interest group, the decision was that are we going to prepare a project authorization request inside the IEEE 802.11 or not? And to develop that project authorization request, we started a study group. After the study group's approval by the working group and the IEEE SA, we have a task group, and the main goal of the task group is creating the draft standard. The draft standard is finalized inside the 802.11bb, and we had letter ballots to check if the draft standard is ready for the world. Then comes the IEEE SA, and in IEEE SA, we have what we call the SA ballots. During the SA ballots, IEEE Standards Association actually announces to whole world there is such a draft standard, and if you are interested, you can part of the voting committee. So, with the Standards Association ballot finished, we finalize our work, and the Standards Association checked our whole process and recently actually approved it.
Just to add to that, Tuncer, compared to some of the other standards works, the IEEE is an entirely open for anyone to join and participate as an individual, or albeit even if they're sponsored by or affiliated with an organization. And this is really important because all of the work within the IEEE, certainly in the IEEE 802.11, is transparent for anyone that is interested from the very beginning, from draft one of Wi-Fi all the way through today, and all the work that we've done in 802.11 is publicly available, and all of the comments and all of the collection can be viewed by anyone that is interested in reviewing the work and participating, of course.
Yeah.
Great.
Then let me give the website here as well, so they can go to mentor.ieee.org and choose the 802 standards, and from there actually they can see all of our documents related to 802.11bb. Thank you.
Wonderful. So how are you more personally involved with Li-Fi? We'll start with Nikola here. I know you're the, of course, IEEE 802.11 Light Communication Task Group Chair, and you're also VP of Standardization at pureLIFI. Can you elaborate a little bit on those?
Yeah, absolutely. So, as you mentioned, I'm the VP for Standardization and Business Development within pureLIFI. pureLIFI is the leading provider in Li-Fi and wireless technology. It's an organization that was co-founded by Professor Harold Haas back in 2011, and it's been working on this technology for well over a decade now, really trying to perfect bringing Li-Fi to the market. To that extent, the company has gone through a range of world's firsts, introducing the world's first Li-Fi system, the Li-First, all the way through to the world's first fully integratable light antenna module, the Li-Fi, the LAM1, which is designed to go into mobile devices and laptops and be actually integrated with the Wi-Fi chipset. So pureLIFI has sponsored my participation and work within the IEEE 802.11 BEB, and the company has been able to make great progress in terms of resolving some of the challenges that were previously considered unreasonable or impossible to be done. Quite frankly, it's a passion project that we've been working on to get Li-Fi to be part of this Wi-Fi family for many, many years. I think Tuncer outlined the process really, really well, but that process was started back in 2015 with some of the earlier prep work before that initial topic interest group. So it's an ongoing process to really bring awareness to the world about the existence of Li-Fi, about how we can actually support the development and additional use cases that it opens up. And to that extent, Pure Li-Fi has done some of the world's first across a range of, honestly, use cases and integrations and technology developments. And from my perspective, I'm really grateful to have had this opportunity to work within the IEEE 802.11 and help support and lead this effort to get Wi-Fi a standard that can seamlessly work with pretty much any Wi-Fi device out there in the world today.
Oh, amazing. Yeah, it's so interesting hearing about the background of how that came about and how, like you said, it's such a passion project for you that really comes from the heart.
Absolutely, yeah.
And for Tuncer, so you're the IEEE 802.11 Light Communications Task Group Vice Chair, and you work on this as well as senior technical staff at Ofinno. Could you elaborate on those as well?
Look, my work with the IEEE standards actually started with when I was a PhD student. At that time, ultra-wideband standards was developing by the IEEE SA as well. And after my PhD, I started working for the National Institute of Communications Technology in Japan. And we were part of the 802.15 group. And we developed some standards there, and I had positions like secretary and editor similarly. In 2014, I went back to Istanbul and started working as a university professor. And I was looking for different areas that I can contribute for the standardization and do my own research as well. And one of them was actually light communications. Me and with the Professor Murat Uysal had a project, and with that project, actually, we had funding to develop light communication systems. And I became again part of the standardization, and we actually provided the channel models that anyone in the world can download and check for the light communications. We worked on the use cases. We worked on different technical aspects of the light communications as well. Afterwards, actually, when the light communication works is almost over, I became part of the Ofinno, and now I am working for the next generation of Wi-Fi systems, which will be the task group BN. So using basically my both knowledge of the standardization and my academic background, I try to help both the process of the standardization and also publish some papers, write some patents. So I basically contributed all parts of the standardization, I can say.
Yeah, and I'd just like to add, Tuncer was great help in many times helping steer some of the conversations during some of the more heated debates to make sure that everybody stayed even keel and all viewpoints were considered reasonably.
A very important factor as well, for sure.
Absolutely.
So in the last couple of weeks, we put out a call on social media wondering what questions people have regarding Li-Fi. And one of the biggest ones that we had that came up a lot was, what will Li-Fi look like for people in using it at home or in businesses? Like, will there be a Li-Fi router? How exactly will that work? I wonder, Nikola, could you speak to that?
Yeah, of course. I mean, I think when we're looking at how routers and look like for the home and how the internet is actually developed through this process of IEEE and how it links with the rest of the world, it really boils down to just the same Wi-Fi capabilities, right? So for example, you have a customer premise equipment like Wi-Fi, like a Wi-Fi router, right, that you buy in your home now.
Mhm.
Well, you can have exactly the same capability, except just bringing in Wi-Fi into that same mobile device. The big difference is potentially where you locate that, right? So for example, meshed Wi-Fi is really getting a lot of momentum these days. So there's nothing that actually prevents people from having that new device potentially located in the ceiling and it doing both RF and light, depending on the type of
Oh,
device that's connecting into it, depending on the channel that's open, depending on what is actually the best use of the wireless spectrum. In terms of products, again, there's a range of factors that are out there, and some companies already have 802.11bb pre-compliant or pre-standard products that do that, right? They take existing Wi-Fi chipsets and they augment it through the light medium, and they're actually providing that kind of broad coverage in a zone with things that are designed to be integrated into the ceiling, like light bulb, effectively, or just another Wi-Fi access point. Again, we talked about some of the commercial applications. Well, actually, Wi-Fi routers in commercial buildings are very frequently on the ceiling itself already.
mm,
Just the nature in which the organizations build out their Wi-Fi network and how you get coverage and how you structure the connectivity. Well, that's perfect location where you can add Wi-Fi, right, or Li-Fi into exactly that kind of system architecture where you have these access points in the ceiling already being powered with power over Ethernet. Again, another IEEE 802 technology with a single cable providing both power and data to give you that wireless connectivity. And again, these will be likely hybrid communication nodes in the same way that current routers have 2.4 and 5 gigahertz coming in with 6 gigahertz now. You'll have exactly the same kind of spectral choices in addition to the light spectrum that would be used as necessary for the use cases that make the most sense. And I think there was a follow up to that question, which was, how do we see that coming into the home?
mhm.
As any technology, it takes time, right? So we're going to talk in a minute about kind of use cases and various aspects of that. But at the end of the day, Li-Fi as a technology has been shown to improve wireless connectivity from both kind of a cybersecurity perspective, a physical security perspective, a privacy perspective, a data density perspective. And all of these aspects are becoming increasingly important as the world that we live in grows to be more security conscious, more connected, more focused on the robustness of that wireless link, because your data is now very much your data. And so to that extent, Li-Fi will probably start with, niche applications into maybe, defense space and things like that, and then progress through until it reaches the end consumer environment once it's very mature. Is it going to be an 802.11bb exactly? I don't know. I hope so. But it will definitely be something of that nature, because you have to understand that standards themselves are also evolving, right? New technologies are coming in, new capabilities are being brought in. And
Mhm.
that's why being part of the 802.11 family is critical, because in 30 plus years of Wi-Fi, we still have backwards compatibility. And that's something that is really important for anybody that is considering getting Wi-Fi and bringing it into their enterprise or their home network. Knowing that it comes from the 802.11 family ensures that compatibility and backwards compatibility in particular will be there even as the technology progresses and becomes better into the future.
Yeah, that compatibility is a big thing there for sure. I mean, no one wants to have devices that get sunset because they upgrade something. They want everything to be able to work all the time, and having that IEEE 802.11 uh, background with it, people know it's just going to work. So it's a great point.
Absolutely. Yeah.
So our next question here, Nicola kind of touched on some of this, but I wonder if Tuncer can elaborate. Looking at what are some of the use cases you can envision. Touched on certainly some environments that are going to be more challenging for RF, and maybe there would be like RF sensitive environments. What are different ways in which this could be used?
Thank you. As Nikola mentioned, that the home and business environments will be perfectly fine with the Li-Fi use cases. And actually, when we were developing the standard, we look at the requirements for home and business conference room environments as well. On top of that, actually, Li-Fi is well suited to the RF sensitive environments, which could be hospitals, which could be some of the factories that you don't want any RF interference, that you are related to that. And the second one is the secure communication, anti-jamming communication, where you don't want actually your data is going um, outside of your building without your permission, I would say. The beauty of the Li-Fi is that the signals will stay in one room, and actually if you are arranged correctly in one specific location, for example in a museum environment, which you get the the, the data, the signal at in front of a specific place, that the Li-Fi systems will work perfectly. Another use cases is that, for example, the fleet of trucks, so car to car or truck to truck communication. So you don't want, in such a case, also no jamming, and you want to have a constant communication between those vehicles. I know that there are systems which are testing the Li-Fi systems very successfully. Another use cases, actually, we were doing a project on that one, is that the in-plane communication. So we have the lights of the planes already there, and there are systems which are checking that if we can have Li-Fi systems inside the planes. So as I would like to repeat, that if you are in an RF sensitive environment, such as hospitals, if you want to have a secure environment, or if you are just in your house, in your conference room, which you are want to keep your data inside, you can easily use Li-Fi.
Maybe just to tag on to that, right? In terms of use cases, we're seeing a lot of these being addressed, with customers actually buying equipment exactly for these use cases, whether it's in the defense sector or the aerospace sector or the manufacturing sector. We're seeing this increased deployment of this technology. And I think the IEEE 802.11bb in particular is really helping accelerate some of that demand, because people are now, number one, confident of backwards and forwards compatibility. Number two, they know exactly how it will integrate into existing systems, because pretty much everybody already has Wi-Fi deployed in one form or another. So they understand from a security perspective and from an infrastructure perspective what that means. Whether it's you in the home that plugs it in and it works, or it's much more complex deployment across commercial, commercial grade and enterprise grade wireless systems with controllers and backend security checks and things like that. Knowing that you have now an 802.11 standard gives you that confidence that everything that you've done to date is directly applicable, whether you're using the light spectrum or the RF spectrum, and there's no difference between them. And as a result, a lot more use cases are opening up, and people are a lot more willing to actually deploy the technology and really use it today.
Sounds like there's a lot of different potential uses for this, and I mean, the sky seems to be the limit. A lot of different things that maybe we'll discover that can end up being great use for this as well.
Yeah, you're absolutely right. I think there's still a lot of use cases that we don't know, right? When I think it's pretty much the nature with every technology. When it first shows up, everybody says, we don't really
Mhm.
need it. And then as time goes by and the technology evolves and people's ideas of what was possible become everyday, right? If you told
Mhm.
somebody, I don't know, say 20 years ago, do you need 100 megabits per second? I would have been the first one to laugh at the idea. 20 megabits or 100 megabits. Why would you need that, right? But looking back now, you're thinking, I'm not really too sure this 100 megs is enough. I think I probably need closer to a gig just to be more comfortable with my online experience. And even what we're doing today, right? This would be considered the effective equivalent of broadcast television, and yet here we are
Mhm.
streaming on a platform, and it's likely that this content is being consumed on a mobile device, whether it's a laptop or a tablet, and it's likely, or a mobile phone, and it's likely that that mobile tablet is connected wirelessly, right? just one example. So as Li-Fi comes into its own, as people start realizing some of the, again, security, RF, um, security and sensitive areas that this technology can bring in, and in particular, as people start understanding how it can improve the information security and cybersecurity, we're going to see a lot greater uptake of the capabilities.
You kind of touch on some of that here. Um, One of our next questions is about whether this will replace or complement traditional Wi-Fi, and it sounds like, many ways this is a complementary technology that will complement traditional Wi-Fi, perhaps complement cellular systems. A lot of different ways that this is another tool in the toolbox. Do you want to have Tuncer touch on that?
Well, I would say actually, like wireless communication technologies always complement each other. So it
Mm.
is not even like from looking from the Wi-Fi point of view. We have Bluetooth, cellular phones, we like the ham radio. Every system has its own strengths and weaknesses, and with each new technology, we are adding a new feature, a new system that we are going to use, and we will have a better connectivity throughout the world. So we are going to complement the Wi-Fi systems, and also like even if you look at from the Wi-Fi point of view, Wi-Fi has 900 megahertz systems. Wi-Fi has 60 gigahertz systems, and they are complementing each other. So, and as a result, Wi-Fi will be a great complement to the traditional wireless communication systems.
When are we going to be able to use it? Might we begin to see devices using Wi-Fi, or are there even already some devices using this technology?
There are definitely some devices that are already using this technology. I think there's a few different providers out there in the market that are already offering Li-Fi enabled devices. Obviously, pureLIFI being one of them that is offering, 802.11bb pre-compliant systems moving into the future. And I think that will just accelerate, right? If you look at what the standard provides, it really is just taking a Wi-Fi 4, Wi-Fi 5, or Wi-Fi 6 chipset, like the actual communications system, and simply changing the antenna element. Instead of the antenna going out to be a piece of wire that is operating at, say, 5 gigahertz, it is now connected to an optoelectronic front end that is sending it through the light
Oh,
medium. And that's, there's really almost no impact on the chipset design itself. Actually, I'll argue there is no impact on the chipset design itself. And as a result, anyone that wants to spin up a company in the space is welcome to do that. And the standard allows for that interoperability between these different systems. In terms of devices coming into the market, I think we're going to see the same evolution that Wi-Fi saw in the early days. At the beginning, there will be dongles, and that's what you have today. You have dongles that are using the light spectrum, using 802.11 technology to connect to these Wi-Fi networks. Over time, as that demand increases and as the cost and complexity of integration decreases, you're going to start seeing devices that actually have it built into them, whether that's laptops or tablets or phones. That will obviously depend on the segment, the interest there, and the demand signal that's coming in from the customers. I would argue, given the pace of development of the technology, it could be as little as a couple of years before we see these devices available in the mass market. Obviously, I wish I was a fortune teller, but
mm.
I think, yeah, looking at the pace of change and the development of the technology, it shouldn't be too far out.
Being focused on the light, visible light, and infrared spectrum, one of the questions that comes up is, does this work both during the day and at night? Does it work outside? If you've got situations where there's a lot of ambient light, will this still work? Is that built into the standard as well?
Yeah, absolutely. I think Tuncer can expand on this, but um, effectively, this is definitely a technology that can work irrespective of the background light. So there's two factors for this. First of all, the IEEE 802.11bb specifies a light spectrum range in which devices are required to operate, and that's between 800 nanometers to 1,000 nanometers. And this was chosen for a range of reasons, including the availability of optoelectronic elements that operate in this space that are, cost effective and easy to integrate, and really broadening that ability for anybody to come in and, use that technology. The second aspect of that is, well, at this point, that's not really a factor, whether it's day or night. The infrared spectrum is something that humans can't see. And so you can quite comfortably be in your darkened living room, but still streaming your favorite shows on your TV using Li-Fi. In the meantime, offloading that high demand, potentially 4K, or some people are talking about 8K in the future from the TV, you're offloading that to the light spectrum so that no one else in the room needs to suffer from that, and they can be free to use the RF spectrum for other connected devices that maybe are not as readily available and maybe are not as large of a consumption target for data, right? Think sensors, think monitors, and whatever range of other connected devices we have, fridges, fridges or washing machines or whatever else. So it definitely will work day or night. The aspect with respect to, does it work in significant sunlight conditions? So Li-Fi operates by changing the intensity of the light modulation. So the level of DC light, let's call it that, of ambient light that's present, doesn't meaningfully impact this rate of change. What does impact it is if you have so much light that you completely saturate the detector, then it won't work. Obviously everything has a dynamic range. RF antennas have a dynamic range, and if you start blasting a lot of energy on the spectrum in which these RF antennas operate, you're going to jam them. And the same thing can happen with light. If you have a lot of optical energy that is incident onto these Li-Fi devices, then you can blind them in the exact same way that you would blind a human, or you would blind a laser of any kind, or a photo detector of any kind. What I would argue with Li-Fi is, if you have so much energy that these detectors are blind, then you can pull your curtains down. And that's one very quick way of solving it. Or you can point them away, because light is very directional. It's very, very directional, right? And so if you have these issues where you have a lot of incident light, a small change in the direction of that viewing angle dramatically changes the power that is incident on your detector. So you can quite easily get away from being jammed effectively by that incident power. And that's just not possible with RF. Tuncer mentioned it right at the beginning when he was talking about use cases. Let's take the use case he mentioned with vehicle-to-vehicle communications, right? Let's say we have a fleet of trucks and they're self-driving vehicles, right? And they're moving along a road. This convoy can be, 5, 10, 20, I don't know how many vehicles long. Well, if they all lose communications and the front truck breaks, and you want them really driving pretty much neck and neck, really close to each other for optimum efficiency in terms of airflow and aerodynamics and fuel efficiency,
Right.
and things like that. If the front truck breaks and that is never communicated to the second truck or the third truck, it's going to be pretty disastrous, I would argue, right? Well, with Li-Fi, that blinding can't happen, because your detectors are directly viewing at each other, and there's nothing that can get in the middle of it that would jam that light signal, right? So I think from a spectrum perspective, we're talking 800 to 1,000 nanometers. From a jamming perspective, from a significant power, yes, that's always possible. You can always saturate receivers with enough power, but I would argue with light, it is infinitely easier to remove that effect, whether by changing the viewing angle or by pulling down the curtains, than it would be necessarily to get rid of an RF jamming source, which can quite literally be anywhere around you. Tuncer, if you want to add or clarify something on that.
Yes, and I was going to actually think about more of the outdoor implementations, and we worked on those parts as well. As Nikola mentioned, directionality is a great help. So normally, like if you are talking about the sun, and if you are designing an outdoor system, you know where the sun will be, you know how strong the sun is, and you can basically design a shade in front of your receiver to reduce the effect of the sun. And regarding indoor uses and so on, since Nikola mentioned that we are operating in the current Li-Fi systems mostly in infrared, actually you don't have any problems for even from the sun operation. So you need to design your system so purely that the Li-Fi wouldn't work. But normally, especially in professional deployments, it is so easy to take care of such disadvantages.
So yeah, it sounds like there's a lot of flexibility
Yes.
within the deployment and within the use of it, and with the complementary bands and that type of thing. That there's a lot of different ways that these can be used in virtually
And
any
also,
situation.
for example, the diversity is there as well. So if I have multiple lights on a car, each light can be used a transmitter, or I can put a multiple receivers from each light source. So I can have MIMO communication, which is a part of the Li-Fi systems as well. So we can actually increase the diversity and increase the robustness just using MIMO.
All right, that's great. So I think we've touched a little bit on this one already, but I wonder if we can elaborate on it. How is Li-Fi both the same and different from traditional RF-based Wi-Fi that people may know about?
Um, Nikola already mentioned, and actually after me, maybe he can put more in details. In terms of what we have inside the chipset, they it, Wi-Fi is using the traditional Wi-Fi chipsets. So the main difference is the spectrum that we are using. The traditional Wi-Fi is using the RF spectrum, whether it is 2.45 gigahertz, 60 gigahertz, 900 megahertz, etc. We are using light spectrum, infrared spectrum. So the background parts, the MAC layer and above layers are the traditional Wi-Fi systems actually, and as a result, it enables working with other Wi-Fi systems much easier. So you are using the same technology, and by using a different part of the spectrum, we are gaining some advantages, which we mentioned as well: security, being robust against RF interference, and uh, operating in RF sensitive environments and such as. So if you look at the circuits, basically up to the transmitter part, we are the same. Our transmitters, the end transmitters and the receivers. So our antennas and the circuit connected to the antennas are different. We are using photodetectors and we are using LEDs. So Nicola, what else would you like to add on it?
I think that's a pretty comprehensive summary. Yeah, I think it's the same, right? With the exception being that instead of the signal going over RF, it's going over the light spectrum, and that introduces this range of benefits. I don't think there's I don't think there's any major differences that are required. And in fact, I would argue, and that's why we did it in 802.11, the two are very, very similar. But when you're adding this significant license exempt spectrum that's available globally to anybody with no regulatory pressures on it, the device that you design to work in, I don't know, say Chicago, would work equally well in Shenzhen with no need for regulatory injections to enable that operations. And when you have these systems, when you have Wi-Fi that's running and you have Li-Fi, offloading to the light spectrum actually makes the Wi-Fi experience better for everybody else that's there. Because we will never have everybody on Li-Fi. That's just never going to happen, right? In the same way that my devices today have 4G, 5G, and Wi-Fi, um, it will continue to be the same. However, if I have a lot of users on my RF channel, if I can offload them to a different part of the spectrum, the performance in terms of latency, channel congestion, throughput, everything else improves for everybody else that is on the RF spectrum. And I think that complementarity is really the key element. And to a great extent, that is possible because 802.11bb is Wi-Fi just over the light spectrum.
Yeah, I think that's a great point. In some ways, we're able to do that today. My router may have IEEE 802.11, 2.4 and 5 gigahertz. Maybe I have my smart home devices set up for the 2.4 gigahertz band because they don't need as much bandwidth, but maybe the smart TV and my laptop might be on the 5 gigahertz band. So having Wi-Fi in the mix just enables you to do more of that, and having the most appropriate band or the most appropriate type of device for each thing that you're using in your home or your business, I think can only make things better overall. To your point there.
Yeah, I mean, absolutely, and you've hit the nail on the head, right? In the UK, we have a saying, "horses for courses," which is use the
Mm,
technology for the areas that it deals with very well. So, Li-Fi is never going to deal really well with devices that are in a person's pocket. It's just,
sure.
not really going to satisfy that use case. And I think it'll take a while before it's in my smartwatch, let's say, right? Again, you lots of angles, lots of permutations, but a static
Hmm.
TV display, there's no reason for that to be on a congested or increasingly congested 5 gigahertz spectrum. And I know that 6 gigahertz is opening up, but again, if we're talking about spectrum, and Tuncer is one of the leading people that's helping the IEEE 802 in general in terms of collating spectrum and having some of those discussions. But the US has, let's say, I think 1200 megahertz. I'm not 100% sure, but I think it's over a gigahertz of additional bandwidth in the 6 gigahertz spectrum, right?
Hmm.
Well, that's not exactly the same in Europe. In Europe, it's just over 500 megahertz. And if you look at, let's say, China, there is no 6 gigahertz spectrum, period. And if you look at
Wow.
India, you're getting differences. And so even though we talk about having this 6 gigahertz spectrum that's free, it's true, it's free and it's freeing up, but they're not the same, right? And the quantity is not the same, and the exact channelization is not the same. And all of these things are things that are already very, very well aware for the Wi-Fi community, and they're handling them, obviously, right? There's commercial products they're rolling out, regulation is in place, and things like that. But as time goes by, that channel will also become congested, right? And light is one of these things that is completely license exempt, which means if we design a system that operates at, let's say, 900 nanometers,
Hmm.
the exact same technology, identical, with no changes in the transmitter or the receiver, can work in your room, in my room, or in, again, I'll say, let's say Shenzhen, right? All across the
Sure.
globe, regardless of where we are. And that's really, really powerful because the entire kind of regulatory burden is then lifted.
Yeah, that's an incredible thing to have the same device be able to work just as well, literally anywhere around the world, or even in space. Who knows, right?
Absolutely, yeah. And
So,
actually, there is, yeah, absolutely. I mean, I think Li-Fi in space is, I think Wi-Fi currently is in space. I'm pretty sure we were at a summit where Dorothy Stanley, who is the chair of the IEEE 802.11 working group, and she actually mentioned that I think the ISS currently has Wi-Fi, and
mhm.
it's running. So in the future, why not also complement that with Li-Fi? I'm not entirely sure that congestion is a problem in the ISS, but we'll see.
All right. So, what sorts of things, and I think we may have touched on a bit of this already, but what sorts of things will users be able to do with Wi-Fi that maybe traditional Wi-Fi can't do or can't do as well today? I wonder if Tuncer can speak to that.
Um, we discussed these topics, but I want to again repeat it. The one of the main things is the security. So, if you would like to have no leakage of your data, Wi-Fi is a great solution. It stays in a room. If you are close your curtains, nobody can actually get your data. That's one of the things. The second one is again the RF sensitive environments, and I mentioned hospitals and similar environments, but also the radio astronomy is an important topic, and in US, close to some radio astronomy stations, you cannot have any RF transmitter. So not only Wi-Fi, you
Yeah.
cannot even have Bluetooth. They don't allow it. In even in those things, you can use the Wi-Fi for the communication purposes because again, light is there, and the sunlight causes enough interference to the radio astronomy, so your light wouldn't affect it much. So this is one of the interesting things that Li-Fi can do. And other than that, again, if you are worried about interference to your systems, like we were mentioning about the factory environments, and they want to actually keep their communication interference free, and they tested their systems. They don't want also the cables, like in the factory environment they don't want cables, they don't want interference. So in both cases the Li-Fi will be a good solution for them.
Just to agree with everything that you've said, and Li-Fi gives you the security of a wired system with the flexibility of a wireless solution. That's basically what it boils down to. When you're talking about RF emissions or susceptibility to them, it's not there. And as Tuncer said, that is important in, for example, manufacturing areas or MRI spaces or areas near radio astronomy, right? And a whole host of other things, like we mentioned earlier, right? We cannot possibly know all of the use cases. Then, of course, there's the security aspect, which is, as I said, I think important and likely growing more important. Wi-Fi has great security. Don't misunderstand me. It is absolutely brilliant, right? Li-Fi is just improving that from a physical security perspective. Yeah. It's not going to help if someone has an application that's already on your laptop and you've downloaded it and it happens to be malicious. However, if you are someone that is concerned about jamming or RF sensitivity, or you live, for example, in a very densely high density area, right? If we think about, say, South Korea, right, in some of the larger areas of Seoul, you'll see hundreds of Wi-Fi access points, right? And how you cope with them. Well, wouldn't it be nice if you had a system and connectivity vehicle to just provide your critical information inside your home, knowing that your data is just your own data, and you have this reliable, robust connections? Because once you establish a connection between, let's say, an access point in your ceiling and your TV, that connection is going to stay there for a long time, right? It'll be something quite challenging. It doesn't matter if your neighbor upstairs got a new router or not. It's still your connection. So getting that robustness, that resilience is also very important.
If you're a student or a professional wanting to get involved with the Li-Fi development process, or maybe you're just wanting to stay up to date on these developments as they come out, where should people go, or how can they find out more about that? Maybe we'll start with Tuncer and then go back to Nikola.
Okay. IEEE 802 has a website, IEEE802.org, and from there they can actually see all of the activities of the IEEE 802. And I mentioned mentor.ieee.org, where they can find all of the documents that we are going to have as the IEEE 802 group. On top of that, we have a LinkedIn page, IEEE 802, that they can join, and we announce our meetings. And one of the, when I was a student, actually, I couldn't join the meetings. I didn't have the financial backup. I was checking for the documents but nowadays, after the COVID, at the moment, IEEE 802 allows online attendance to their meetings as well. So if they want to attend and listen what the IEEE 802 is saying, if they want to make presentations, they can actually join IEEE 802 meetings online as well. On top of that, two more points, that IEEE 802 standards is available through IEEE, which we are going to, I believe, provide the websites how they can buy the standard and get the standard.
I would like to call your attention to the Light Communication Alliance, in very much the same way that the Wi-Fi Alliance or the Ethernet Alliance are looking at educating the market on the value, benefit, and capabilities of those different technologies. The Light Communication Alliance is trying to do exactly the same thing for light communications. So specifically, the light communications is a pretty large field, and it covers everything from free space optics, which is point-to-point, long-distance, optical wireless communications, to Li-Fi, which is what we've been talking about, to optical camera communications, which is using actually the camera on smartphones to receive broadcast messages from, modified lights. And our mission is to really try and educate the world on the benefit of these technologies, and of course understand some of the challenges with their deployment. So we would welcome everybody to join us. Please visit our website at the Light Communication Alliance, and yeah, just let us know, and we'll be happy to have conversations with everybody. And then, of course, as Tuncer mentioned, stay in touch with the 802.11 developments.
So just as we're wrapping up here, wonder for a couple minutes each, if there's anything you'd like people to know about LiFi that maybe we haven't touched on yet, or that you want to elaborate on. So we'll start with Nikola, and then go to Tuncer.
Yeah, I guess the key message, to just convey it one more time, is LiFi is here today, right? And that's very important. It's not something that it's one day it will happen. It's something that's out there in the future. Actually, it's here today, and people can buy 802.11 BB, and I keep saying pre-compliance, but compliant products today, and that's something that is really important, that is going to help facilitate that. The pureLIFI light antenna module is one example of an optoelectronic light antenna that helps enable existing chipsets to be connected. And we know that one day everything and everyone is going to be using this technology, or at least that's our belief. So it's very important for us to understand that LiFi is never going to replace Wi-Fi. And I know there's some messaging out there about 100 times faster than Wi-Fi. That's not true, right? We're just engineers. We're not magicians. Optical wireless
Sure.
communications, some of them, sure, they can be not 100 times faster. They can be 1,000 times faster, right? If you look at fiber optic communications doing, most recently at the Optical Communications Conference in Europe, in Glasgow, they were showing systems that were doing 800 gigabit over a
Wow.
single optical fiber, right? I mean, if you take that, you shoot it over free space, and you call that Li-Fi, sure. I mean, that's hundreds of times faster than Wi-Fi. But that's not what we're talking about here. What we're talking about is 802.11 BB and Li-Fi in real life. And that is offering hundreds of megabits per second, very much the same as what the Wi-Fi standards are offering it, but they're offering it over a clean, uncontested, uncongested, dedicated channel, which gives you a lot of reliability, a lot of robustness, a lot of security, for applications that need that. So don't wait for the next decade and think that this is something that's going to happen eventually. It's actually something that's happening right now, and it's an opportunity that everyone can be involved in. Thank you. Oh yeah, and I'd like to say thank you. I think that's really important. I think getting the IEEE to work with industry to develop these standards and create that platform where these standards can be discussed and use cases can be brought forward, and it can be a very open, very transparent, very like-minded conversation. Even though there might be some heated debate sometimes, I think that's absolutely critical for the development of the technology and the proliferation of the technology throughout the world. So thank you.
All right, thank you. Yeah, the future is now. We love to hear it.
Thank you. I would like to talk a little bit more as the IEEE to Public Visibility Standing Committee Chair. So, as we mentioned, that IEEE 2 is an open process, and by open we mean that all of our documents are available. This includes, for example, the channel models for the Li-Fi systems as well. So, as a university professor, PhD student, master students, you can download those systems and start your own simulations. On top of that, all of the working groups have wireless next generation standing committees, which are keen to listen new ideas from companies, academia, etc. So previously, the wireless next generation group listened new Wi-Fi 7 system models, how artificial intelligence can work, and so on. So if they are interested in presenting their own work, as IEEE 2 we are ready, they can reach me from LinkedIn, from my pages, and so on, and I will actually introduce them our wireless next generation or the next generation chairs in each specific working group for them to make the presentation. So we are developing technologies for the humanity as IEEE, and we are open for everyone to join us. Thank you.
Great. Well, thank you so much. It's been wonderful having both of you on here today. We really appreciate your time and really appreciate all our viewers for joining us. Be sure to check out the survey link. You can also sign up to get more information on this. And if you're interested in buying the standard as well, the IEEE 802.11 BB standard will also have that link available. So thank you once again, Tuncer and Nikola. Really appreciate having you here today.
Thank you so much for the opportunity, Corey.
Thank you very much.
Thank you all.